What is this asking? This is M2. I need more space. This is M1, 2. So M1, 2, we ask about M0, 0, right? Because, no. M1, sorry. Yeah, okay. I is 1, so we're asking about M0 and 2 minus x1 is 0. Or M0, 2. Well, this one is true, and M0, 2 is false. But it's an or, so this is true, so this is true. Right? It says, yes, we can get a subset summing to 2 from just x1 because x1 is equal to 2. Ha, isn't this fun? Okay, so can you, we're going to erase some of this stuff. And I have to start the timer again. Okay, so we're going to erase some of this stuff. And then we're going to try to write a little program to do this. To fill in this matrix. Okay. Do we want to do another of these, or do people get this? Does that say that mij equals mi minus 1, j minus 1, or mi minus 1j? This says, okay, I'll write this bigger. When we get to the program, so you write mi0 equals true, right? So that says this column is true. M0j equals false for j greater than 0. So that says that this row is false except for this one. Okay. Now, for I equals 1 to, what are we going to say? Let's say that this is m. Let's say that we have m elements. M is the number of elements that we're allowed to choose from. For j equals 1 to n, yeah, okay. Now we get this thing. Mij equals m I minus 1 j minus xi, or mi minus 1j. I minus 1j. So this is saying we take xi, and so we want to get exactly the sum j minus xi using x1 through xi minus 1, and this one is saying we don't take xi, and so we want to get sum exactly j from x1 to xi minus 1. Okay? So that's n4. n4. n4, n4, print oops, I'm using big M as my matrix and little m as my array. Let's call this A, just so that people can't get confused. Well, in the lecture notes that people won't get confused. In the lecture, people may get confused by me switching letters. I was writing the lecture notes for edit distance yesterday, so I wasn't preparing this lecture. Okay, for print A, M, N. Okay, so what is Mn? Can you get sum exactly n, which is the target? So now this is n. Sorry, not t. N. Can you get sum exactly n from a subset of the elements? And that's exactly the question we're trying to answer. How did we define m? It's not j m minus 1 j minus 1. But it's not j minus 1, it's j minus xi. Remember I said before when we were doing edit distance, we just had to consider the stuff that's above and to the left, but okay, let's fill in some more of these so people can see what's happening. Okay, so can we get some exactly 3 from subset 1? So this is all going to be false, actually, because it's asking, because actually the only sum we can get from one element from x1 is x1, or 0. Okay, so it's true we can get from x1, just choosing a subset of x1. If we choose x1, we get x1. If we don't choose x1, we get 0. Okay? So now, can we get a sum of 1 from x1 or x2? No. Okay. I'm just filling this in quickly so that people can have a demonstration, because otherwise we're going to run out of time. Can we get sum exactly 2 from a subset of x1, x2? This is getting a little bit harder. Yes, but let's look at this program. So what we do, we look here and we say, okay, so aij, so we're looking at a 2, 2. So we look at a1 and 2 minus x. So if we decide to take x2, then that's a 5. So we're trying to get sum minus 3 from just x1. So that's not going to work. So this one is false. But this one, then we say, okay, so that was false. But then can we get sum 2 from just x1? And we look and we say, okay, so this is going to be a1, 2. So this was a1 minus 3. This is not going to work. This is 1, 2. So can we look at 1, 2? It's a true. We take the OR of a false and a true, and it's a true. Okay, now can we get sum 3? So we look at, if we take 5, this is going to be a minus 2, that's a false. Okay, if we don't take 5, we're asking, can we get sum 3 from just x1, and it's a false, so this is a false. This one, same thing, it's going to be if we look over here, it's minus 1, so it's false. If we look down, it's going to be false. Now here, if we look down, it's a false, but if we look right, we're trying to get some, if we take x2, which is a 5, then it leaves us trying to get 0 from, it leaves us trying to get 0 from just a subset of x1. Can we do that? Yes, it's true. Look, it's true. It's right here. We just don't take anything. So this is true. So how about 6? So we go down 1 and we say, nope, we can't get subset of, we can't get sum 6 from just x1, so this is a false. We look over here, right? We're going over 5, we're going x2, over 5 and down 1, and it's a false, so this is a false. Now here, we look down 1, it's a false, but we look over 5 and down 1, and it's a true, so this is true. Yes, we can get a sum of size 7 from x1 and x2, because we take both of them, right? This true came from here. It says we're looking over here because we're taking x2, which is 5, and then we're saying, okay, can we get a sum of 2 from just x1? And the answer is yes, because we just take it because it's equal to 2. Is this another way to solve this problem? This is a boom problem. I mean, it's NP hard to do subset sum. This is actually not bad. I mean, the fact that we can do it in something called pseudo-polynomial time, which means that it's polynomial if the instance is represented, is polynomial in the size of the numbers. So subset sum is NP hard in a weak sense. So actually, it's not that bad, really. Like filling this thing in, people think this is a cute trick. And besides, come on, you just write this little program. The computer is going to do it for you. So we're just going to do like some more of the 8. So we look down. This is a false. We look over here. 1, 2, 3, 4, 5, and we look down. This is a false. And so actually, these are all going to be false because even if we take both of these things, it gives us some of both 7. So I'm just going to fill this in, and you're going to believe me that if we look down, one, then we're going to see a false, and if we look over 5 and down 1, we're always going to see a false. Okay, so now 3. Can we get some exactly 3 from x1, x2, x3? Well, let's see. If we take it, we look over here 8 steps, so we look at minus 7, 2, that's a false, and we look down 1, it's a false, so this is false. Here we look down 1, it's a true. So we also have to, like, if we took x3, it'd be way over here, and it's a false. Here, we look over here, it's off the side of the matrix, so it's false. We look down, it's a false. Here we look over, we're off the side of the matrix, it's false. We look down, it's a false. Here we look down, it's a true. We look over here, it's still off the side of the matrix. But this is a true because of this. 6. Again, 6 minus 8, it's off the side of the matrix, but we look down, this is a false. Here, it's off the side of the matrix. We look down, it's a true. Here, we look down, it's a false, but we look over 8, 1, 2, 3, 4, 5, 6, 7, 8, and we look down and it's a true. Can we choose a subset of x1, x2, x3 such that the sum is 8? Yes, we just take x3. So 9, we look down 1, it's a false. We look over here and down 1, it's a false, it's a false. 10, we look down 1, it's a false. But we look over here, 8, and down 1, it's a true, so the answer is true. How do we get 10? We take x3, which is 8, and then we try to get a subset that sums to 2 from x1 and x2. And how do we do that? We just take x1. Okay, so that's why this is true. So now 11, this is a false. We go over here, 8, 2, 3, we look down, this is a false. 12, This is a false. We look over here to 4, it's a false. 13, we look down, it's a false. We look over 8 to 5, we look down, it's a true. So this is a true. Can you get a subset that sums to 13 from x1, x2, x3? Yes, you take x2 and x3. 14, you look down, it's a false. You look at 6, you look down, it's a false. 15, you look down, it's a false. You look over 8, 15 minus 8 is 7. You look down, it's a true. So there is a way to take a subset of x1, x2, x3 that sums to 15. It's take all of them, right? People could people could fill this in manually, I hope, believe. I mean, you just follow this. It seems to actually be working, which is not guaranteed because it's quite easy to mess this stuff up if you're on your feet in front of a class. Even if the class consists of only 20 people, like less than a fifth of my students actually show up. But it does, you could program this. It's not that hard. I'm sure you could figure this out. Okay, so let's move on because we are going to run out of time because optimal binary search trees is going to be really hard. Okay, so we've used 25 minutes for, that's not that bad. Okay, where did my paper towel? Because I have to, okay, so that was subset sum. NP hard, but you can fill it in, but the size of the matrix, well, the dimensions of the matrix is linear in this instead of logarithmic. So that's why this program doesn't show that P equals NP. Clink does not equal boom because of this. Okay, people understand, right? I take it the laughing LOL. I will take it that people are following. So this was a little bit trickier than edit distance in one way, which is we're not just looking we're not just looking beside us, we're actually looking over at another part of the matrix. Okay. So now let's do knapsack, which is also NP hard, but also NP hard in the weak sense. Which means that we can give a dynamic program for it, which runs in time polynomial in the size of the stuff. What is the key number in the instance? It's the capacity of the knapsack. So I forget the instance we had of knapsack. So that was subset sum. I'm not going to write it. I trust everyone can write knows how to spell subset sum. Okay, everyone knows how to spell knapsack as well, but I'm just... And if in the notes I accidentally write backpack, it's the same thing. How many people in the class? We've stopped hemorrhaging students. We lost like 60 people. I think we've lost 60 now. But we're still slightly over 100. So technically I shouldn't complain. We've lost 60, but we still have like 106 or something. This is not as bad as last year. Last year I lost 82. But I still had 99 people show. Okay, technically I lost 84 because 2 people didn't show up to write the final. But then 99 people actually wrote the final. So I got it down into double digits. But actually now, Zoom just sent me a message saying that now, for free, they're going to upgrade my webinar license to 500 participants. Why they didn't do that a month ago so I didn't have to pay so much, I don't know. But okay. But now I don't think I'm ever going to get a class of over 100. So, okay, knapsack. So knapsack, remember, now we're not trying to get a sum of exactly something. We don't have to exactly fill the knapsack. Knapsack is. So the knapsack looks like this, and we have some items. we have a bunch of things that have weights, and we're trying to pick, so the knapsack has capacity C. Let's say the knapsack has capacity N, just for consistency. And we have M items. And we're going to do basically the same thing with profits and weights. So now, what are we going to do? We're going to do a matrix. So we want AI, so let's say that these items are x1 to xm. So we want Aij max profit. We can achieve, no, this is going to be, from x1 with weight j. Okay. So this is, you have to. I just have to. I do know this, but switching from problem to problem, I have to try to remember exactly how this goes. Okay, so I think it's the maximum profit we can achieve from x1 to j with from x1 to xi with weight j, exactly j. Okay. Now at the end, this means we don't just get to look at one corner of the matrix, because if we look at xmn, that's asking how much profit can we get exactly filling the matrix, exactly filling the knapsack. And it might be that you can get more profit not quite filling the knapsack. So in that case, what you've got to do is scan scan the top row and find the maximum. Actually, row, column, something like that. It'll be correct in the lecture notes. So let's choose something a little bit smaller this time. We could do the same. Okay, we could do, what was it? No, let's not do a matrix that big. Let's just make it say the profit weight pairs are 2 profit 1. Weight 3 profit 4. Okay, so this is weight profit. Okay, so let's not write up there. Weight profit pairs, weight 3 profit 3. And let's say, okay, let's just make it 4 and profit 5. Okay, and let's say that the capacity of the knapsack is 8. Okay, capacity, so let's say n equals 8. Okay, so this is an example. This is in general capacity n. So let's say that these are our items. So actually, okay, our items are weight profit pairs, profits and weights and profits. Okay, so this is going to be weight I, profit I. And this is 2, 1, 3, 4, 3, 3, 4, 5, and let's say capacity is 8. Okay, so once again, we write the matrix. How many of these things do we have? We have 4. And now we remember that actually we want this extra row and column because it makes the base cases easy. Or so this dimension is profit. This dimension is weight. And this dimension is size of the prefix we're considering. So I'm going to write last element. Okay. Actually, I'm not going to write that because it doesn't leave me any space. So this is 0, 1, 2, 3, 4. So once again, I'm reversing things. It will be normal matrix coordinates in the notes. This is 0, 1, 2, 4, 5, 6, 7, 8.